Hey AP Stats, Mr. Zmudio here, doing chapter 13 notes, page 2 and 3. Page 1 should have been done in class, so if you don't have this done, please be sure to watch the recorded Zoom, and page 1 will be done there. So we should be on the page that starts with essential vocabulary. So remember that this chapter is dealing with probability. Chapters 13 and 14, the last unit here before the end of the semester, will be all probability stuff and probability concepts. So some vocabulary that we have to know. The first one is trial, and what a trial is just a single attempt of a random phenomenon. Oops. All right, so I'll give you an example. Let's say we were going up to a stoplight. I'm driving my car. I'm going up to a stoplight. We know that stoplight, probably one of three things can happen, right? It could either be green, it could be yellow, or it could be red. A trial would be if I just go up to one light and I see what it is. Maybe I get up to that light and it's a red light. The one trial, that single attempt, in this case, would be like me going up to that stoplight, and maybe in that case it was red. Outcome would be at each trial, we note the value of the random phenomenon. So maybe in that first trial where I said I went to a stoplight, the outcome we said was red, right? We got up there and it was red. Now let's say my second trial, I go up to a second stoplight, and maybe that outcome is different. Maybe in my second trial, the outcome is now it's a green light. So trial, single attempts, outcomes, kind of what happens at the end of that. An event is very similar to outcomes. It's kind of combining outcomes. So like, for example, if I said, what is the probability of a streetlight being red or yellow? Okay, so this event is being red or yellow. It's one event, but actually combines two different outcomes. It combines the outcome of being red and the outcome of being yellow. So when we say event, we're really just talking about possibly more than one outcome. Okay, so we have trials, we have outcomes, we have events, which is very similar to outcomes, just sometimes can be more than one outcome. And then we have this term sample space. This is probably one of the most important terms here. Sample space is the collection of all possible outcomes. So, for example, with our streetlight scenario, where we can go up to the streetlight and we can have one of three colors, we can say at the sample space, capital S, the three different outcomes that can happen in this case. We can have green, we can have yellow, we can have red. And we denote it with this capital S and these squiggly brackets. All right, just a different example. If I were to flip a coin, what's the sample space? What are all the possible outcomes of flipping a coin? Well, it can either be heads or tails. There's two outcomes here. All right, my sample space just contains two outcomes. It's head and tails. Okay, And with these probabilities, similar to when we did sampling, a key component of all these probabilities is that we want behavior to be random. Right? We got to make sure that we have randomization in order for probability to actually be in full effect. Okay, so we have trials, we have outcomes, events, sample space. We'll do a few examples here. While individual outcomes are uncertain, for a large number of repetition, outcomes are regularly distributed. So, like, what does this mean? Well, just think about this for a second, guys. If you roll one die, just a regular die where my sample space maybe is, 1, 2, 3, 4, 5, or 6. You guys know what a die looks like. I'm going to ask you, hey, what would you expect to get? Like, what number would you expect? And maybe you would guess one of these, but, like, do you really have an idea? Like, who knows? Who knows what we're going to get? But if I said, hey, take that same die, and we're going to roll it 60 times, not just one time, but 60 different times, what would we expect? Well, we would expect these numbers to show up probably evenly. Since there's 6 different numbers, we'd probably expect each one to show, so maybe each side to show up about 10 times. Oops. That's what we would expect. Maybe it would happen, maybe it won't. It probably won't. But what this little statement here is trying to get you to see is that when we increase our trials, or when we have more repetitions, we start to see a more symmetrical distribution. Just to give you a little different example here, if I ask you to flip a coin 4 times, maybe you flipped a coin 4 times, and maybe, let's see, so if we did 4 trials, and we got heads, 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 tails, right? Not really distributed, it's not 50-50, but because of randomness, we don't expect it to be. But maybe we did 100 trials, and then we actually got heads like 48 times, and we got tails 52 times. What this is saying, guys, is the more trials we have, we can start to see that these outcomes become more regularly distributed. All right. The probability of an outcome, I'm sure you've heard of this before. Probability of an outcome is the proportion of times the outcome would occur for a large number of repetitions. So probability, think of as a fraction. It's your outcome that you want over the number of possible outcomes. The set of all possible outcomes of an event, the set of all possible outcomes, we already talked about this. This is the sample space. And here we have an example. If we roll a die and we observe what number it lands on, the sample space contains all possible numbers the die could land on. So if I were to roll a die, what is a sample space? I actually used the same example already. I didn't know it would show up again, but we can roll a die and it can land on 1, 2, 3, 4, 5, or 6, assuming it's a regular 6-sided die. So my sample space would be those 6 numbers. And each of these 6 numbers has an equal probability of getting landed on. Next page, we have an event is an outcome or set of outcomes from a sample space. So think of this, going back to like rolling a die, we have my sample space here, and each of these is an outcome, right? So if I did one trial and my outcome was a 2, cool. But then what if I said, hey, what is the probability that we actually roll a even number? If I asked you, what's the probability that we roll an even number? Well, what's my sample space? My sample space is the same. It could land on all 6 of these. What are the outcomes? The outcomes for an even number are 2, 4, and 6. So there's actually 3 different outcomes that could work there. But what is the event? Well, the event that we're looking at is the even numbers. So the event is just like one thing, right? We're looking at all the even numbers. But that actually consists of 3 different outcomes. That's why we say these events, it's either one outcome or a collection of outcomes. Okay, so now for this example, flipping a coin 3 times. So what is the sample space? Okay. Now, let's just say that we're not going to factor in order, but we could get something like this. We could get heads, heads, heads. We could get tails, tails, tails. Maybe we get 2 heads and 1 tail. Maybe we get 2 tails and 1 head. Anything else? I believe that's it. What am I missing? I guess let's factor in order. We could actually add some more here, depending on if we were looking at what happened first. So maybe these two were, the first 2 were heads and then it was the tails. But what if the tails was actually in the middle? So we flipped the heads, then the tails, then a head. Or we flip the tails, then a heads, then a heads. What else can we do? Heads, tails, tails. Then a tails, heads, tails. Okay. All I did here, guys, was I was just mixing letters around. So like this, if it takes you a second to think about like the different combinations, that's okay. I've done this example plenty of times, so I just know it off the top of my head. But for the sample space, you're really just looking at what are the different ways that we can flip 3 coins. And a good way to think about this, guys, is how many ways are there to flip my first coin? 2, right? Heads or tails. How many ways are there to flip my second coin? 2. How many ways are there to flip my third? 2. Right? So 2 times 2 times 2 is 8. There should be 8 different outcomes in my sample space. And we have that. Okay, so if I ask you what is an event from this sample space, maybe we can say flipping at least 2 heads. If I asked you, hey, what's the probability that we flip at least 2 heads? Well, this one works, this one works, that one. It'll be 1, 2, 3, 4. 4 out of 8. Or 1/2. Or 0.5. So that'd be one event. right? And we can see how that one event actually had 4 different outcomes. Letter C says event T is defined as getting 2 tails. List the set of outcomes. So this one says we get exactly 2 tails. So looking at my sample space, here's one, here's another, and here's another. Okay, so it says to go ahead and list these. So we have tails, tails, head. We have heads, tails, tails, and tails, head, tails. Okay, so that is event T, getting 2 tails, exactly 2 tails. Right? If it would have said at least 2 tails, then we could have included TTT, but it says just 2 tails. Letter D says, what is the probability of event T? So what is the probability that we get at least 2 tails? Well, we said there was 3 of these outcomes out of a total of 8. So our probability is just 3 over 8. With probability, guys, you can leave it as a fraction or convert it into a decimal, obviously between 0 and 1. Your probability should always be between 0 and 1. In this case, 0.375. Okay, so the probability of T occurring is 0.375. If I ask you what's the probability that T will not occur? All right, here's kind of a key thing here. So we know that the probability that T occurs is 3 out of 8. So the probability that T doesn't occur is actually the opposite. It's 1 minus 3 out of 8. Maybe some of you can kind of do this mentally, but the opposite would just be 5 out of 8. Right? There's a 3/8 chance that it occurs, so there's a 5/8 chance that it doesn't occur. All right, and what this is called the complement. Not compliment like I'm giving you a compliment that your shirt looks nice today. That would be with an I. Complement in statistics is kind of the other half of a probability. So the complement and the regular events should always add up to 1. So in this case, the event probability was 3/8. The complement of that is 5/8. And if we add these two, we get 1. Just kind of give you a little another example with this. Let's just say the probability that it snows tomorrow is 60%, hopefully not. And then if I ask you, hey, what's the complement of this? So what's the probability that it does not snow tomorrow? Well, you should be able to just tell me, well, 1 minus 0.6, 0.40. These two are complements of each other because they complement each other so well that they add up to 1. All right. Just keeping going with some of this stuff that I've already talked about, guys. The probability of event A is denoted as P of A. So when you see P of something like this, it's asking for like the probability of that happening. All right, and then just some basic probability stuff here. Simple rules that some of you probably already know, but just never really thought about them. Probability of something happening is always between 0 and 1. Or you can think of 0% and 100%. Probability of 0 means 0% chance of happening. Probability of 1 means 100% chance that it happens. The set of all possible outcomes must have a probability of 1. All this means, guys, is that, let me kind of go back to, I'll give you an example. Going back to that stoplight thing, if we know that we can randomly get a color, yellow, green, or red, and let's just say, for example purposes, that the probability of each of these was actually just 1/3. We know it's probably not true. Like, it's probably more likely for it to be green or red than it is yellow. But let's just say for this example that each of these is 1/3. The set of all possible outcomes must have a probability of 1. So in this case, like, my sample space should add up to 1. 1/3 plus 1/3 plus 1/3 is 1. And the last one here, the probability that an event does not occur. We just said this. This is called the complement. Okay. So the complement of A is usually denoted by this, A superscript C. So if you have the probability of A happening plus the complement, you should get 1. Like, this was like the probability that it rains, or what did I say earlier, snows? Yeah, snowing. This was like my example up here, where the probability that it snows is 60%, plus the probability that it doesn't snow, 40%, should equal 1.